Welcome to this video lecture. Myself Atul Kumar, working as an assistant professor in Department of Computer Science, Rajiv Gandhi Memorial, Government College, Jogindanagar. In this video lecture, I will discuss about record-based logical models. So basically, they describe the data at the logical level. So they are the collection of fixed format records of different types, and in each record we have a fixed number of field, and each field we have a fixed length. So in case of record based logical models, we have a number of record that are of fixed format, and each record have a fixed number of field, and each field has a fixed length. So the first logical model, we have a hierarchical model, and it is one of the oldest model, most recently used in 1960s. And the first commercial DBMS based on this model was information management system. And in this model, the data is represented in case of record, and a record is basically the collection of field values that provide information of the entity. So records are basically organized as a collection of trees. Tree is basically a data structure that contains a root and childs, parent childs. So suppose uh, this one is a root and it has a child. Suppose we have a child like this one is a 2, and the another node I have added is 3, then I have added here 4, I have added here 5. So this one, this kind of data structure is a tree data structure. And basically in hierarchical model, the records are organized in this kind of tree data structure. So in case of tree data structure, we have the first node, that is 1, and it is a root node, and the child of this root node is 2 and 3. So 2 and 3 are the child of this node 1, and the parent of 2 and 3 is 1. Next we have the child of um, 2 is 4 and 5. So the parent of 4 and 5 is 2, and the grandparent of suppose 4 is 1. So each child has only one parent in case in this kind of hierarchical model. So the records are organized as a collection of trees. So in hierarchical models, the we use that trees like data structures, and records are organized as a collection of trees. So the relationship among the data are represented as links, which can be viewed as pointers. So if we want to make a relationship between 1 and 2 in this kind of data structures, so they are represented as links, and they are represented in programming language as pointers. So each record can have one parent record, and they also establish parent child relationship. And parent child relationship here is 1 is to n. So the record on one side is called as parent, so this one is a parent, and the record on n side is called as child record. So n side is a child record and one side is a parent record. So hierarchical model permits only one to many relationships. So next I will show you an example of hierarchical model. So this one is example of hierarchical model. We have three records. One is course, other is teacher, and third is student. And the relationship between course and teacher is a offered by, and the relationship between course and student is a attended by. So this is a hierarchical model. So in the diagram we have three records. One is course, other is teacher and student, and the links indicating offered by from course to teacher. This means that which course is offered by a teacher, and attended by means relationship between course and student is which course is attended by a student. So there are some problems in this example. So it only gives you information about what are the courses being offered by the faculty and what are the courses being attended by the student, but it does not give you the information about what who are the students being taught by the faculty. So as in the diagram there is no relationship between and this uh, teacher and student, means there is no relationship between child, one child and other child. So uh, by this we can't say who are the students being taught by the faculty and who are the faculty being teaching the student. So this is due to the tree structure that I have discussed earlier. This one is a tree structure, as there is no relationship between one child and other child. So we can't make a relationship between one child and other child in case of hierarchical model, and this is the main limitation of this kind of model. So to overcome the next we have a advantages. So the first advantage of this model is simplicity. So it has parent child relationships. So we have different operations like insertion, deletion. It is very easy to implement these kind of operations. The second advantage is data integrity. So each child has only one parent, so it promotes data integrity. The third advantage is data security. So if we want to delete one child, so we need a proper information about its parent. Without getting proper information of the parent, we can't delete that child, and this results in better data security. Next we have a data efficiency. So due to 1 is to n relationships between various records, this model handles very efficiently. So there are some disadvantages of this model. The first one is complex. As we have seen, there are different kinds of links between records, like we have a link between course and teacher. So to implement these links is very complex, and also there is a limitation to implement these kind of links in a real world. The next disadvantage we have a inflexibility. So it also lacks inflexibility. So if we want to change any kind of change in this model, so it is very complex and tedious task. Next we have a problems with data manipulation operations, and also this model lacks standard for database modeling and design. So to overcome these limitations, we have with us network model. So this models also contains the collection of records, and each record is organized as a graphs. So in case of hierarchical model we have trees, but in case of network model we have graphs, and records can have any number of parent records, and thus support many to many relationships among the records. So these records or relationships among the records are represented as links. So this is basically the example of network model. In it is same as I have discussed in hierarchical model, but in case of hierarchical model there is no relationships between teacher and student, due to as there is no due to tree structure in case of hierarchical model. But in case of graph model, in case of network model we have a graph data structure, and in case of graph data structure you can we can just create a link between any kind of record. So there is a link between teacher and student, but in case of hierarchical model there is no link or there is no relationship between teacher and student due to the tree structure. So this model support many to many relationships among the record. So it is more versatile as compared to hierarchical model, and it is standardized as coda sil dbtg, that is the conference of data system languages database test group. So the main advantages of this network model, so it eliminates data redundancy. Redundancy means duplicacy. So there is no duplicate records in case of network model, as we have only many to many relationships, and we have only one occurrence of a particular record in the database which can refer to other records using links and pointers. So also this model requires less storage, and it performs better as compared to hierarchical model. Also it handles many kind of relationships, as we have seen here in this diagram. There are so many kind of relationships occur between different kinds of records in case of network model. Also to access data, it is very easy to handle or access data. Also it promotes data integrity. But due to so many relationships between different kinds of records, this model is very complex, and difficult also arises in querying data, as it requires proper technical or programming skills to make relationship between different kinds of records. Next we have a relation model, and relation model is also a logical model, and it is most widely and commonly used data models used today, and it is basically the collection of tables to represent both data and relationships among the data. So in case of relation model, we have collection of tables, and each table in relation model is called as a relation, which is assigned a unique name. So each relation has a unique name, and each relation has a number of columns representing a field of the relation, and each relation has unlimited number of rows, and each row is a instance of the relation. A row is also termed as a tuple. So suppose I want to give you an example. We have, what is a table? Table consists of rows and columns. So suppose I have a table of student, so I will give this table name as student, student, student. So each table is a relation, so it is a relation, and it is assigned a unique name. I have given it the name of this table as a student. So each relation has a unique or number of columns. So these are first column, this is second column, third column, and so on, and number of rows, these are those second, and these rows may be unlimited. And suppose the column represent the field or attribute of the relation. So in case of student relation, suppose the first uh, field is roll number. So this one is the first field. Second field is student name. The second field is student name. Suppose the second field is student name. Third is father name, father name. Suppose the fourth attribute of this student table is address, a d address. And the fifth attribute, suppose I have, is date of birth, d o b, date of birth. Suppose the roll number, first roll number 1, student name is suppose x, father name is suppose y, date of birth is suppose 1, and address is suppose 1, date of birth is suppose 2, and second roll number is 2, the student name is Y, and father name is Z, and address is 2, and date of birth is 3. I'm just filling the dummy values. So here you can see uh, we can add unlimited number of rows, and each row is called as tuple in this kind of relation. Each row is called as tuple, and also one row is unique to any other row in the same relation. So if we have one row and this is also, so this row, the data in this row is different from data in this kind of row. So each row or each tuple will be unique in the table. So the relationship among the tables will be modeled as foreign primary key relationships. So I will discuss later on what is foreign key and primary key. So this one is the example for relational model. So we have different kind of relations here, student relation, and different attributes of or fields of student is roll number, student name, branch, semester, section, student address. The next relation we have a course, we have subcode, subtitle, subject code, subject title, semester, branch, contact hours. These are the fields or attributes of course. Next we have a teacher relation, and in teacher relation we have different fields like faculty code, faculty name, designation, department, faculty address. Similarly we have other course teacher relation, course student relation, teacher student relation. These are different tables in case of relation model. So we have some advantages of relation model. Firstly, it is very simple to create or implement relation models. Also, to change or update these kind of relation models, to add some kind of field or to delete a row, it is very simple, or so it is very flexible in nature. Also it has a query capabilities. We have different kind of query languages like structure query language, SQL, MySQL is there to just query about these relations and get the desired results. Also we have a mature technology as an advantage, as the technology used in these kind of models is very matured and is in the developing stage. Next we have some disadvantages. These models have a limited ability to deal with binary images objects such as images, spreadsheets, email messages, and documents. Also they require advanced hardware which is very costly, which makes this model very costly. Also these models are not suitable for huge databases that contains a very large number of tables, but are suitable for small databases. So thanks for watching this video lecture.